Most developers building AI apps are throwing away up to 90% of their API budget on tokens they've already paid for. Repeatedly. Every single request. And the wild part is there's a dead simple fix that's been sitting right in Claude's API for over a year now, and the majority of production apps still aren't using it. Today we're going to change that. By the end of this video, you'll know exactly how prompt caching works, why it matters for real production systems, and how to wire it up so your app gets faster and cheaper at the same time. Let's get into it. So what is prompt caching, really? Here's the plain English version. When you call an AI API, you send a prompt. That prompt usually has two parts: the stuff that never changes, your system instructions, your context documents, your knowledge base, and the stuff that does change, like the user's actual message. Without caching, the model has to process all of that from scratch every single time. The static part, the dynamic part, all of it. You pay for every token on every call, every time. Prompt caching tells Claude to hold on to the expensive, static parts of your prompt in memory between requests. So on the first call, you pay full price. On every call after that, Claude reads the cached portion in milliseconds at roughly 1/10 the cost. You're only paying full price for the new tokens, the part that actually changed. It's like the difference between reading a book from page 1 every time someone asks you a question about it, versus just bookmarking where you are and jumping straight to the relevant section. Now let's talk about what this actually looks like in practice, because the theory is easy. The implementation is where most people get tripped up. The first thing to understand is how you actually mark content for caching. In Claude's API, you add a cache control parameter directly to the content blocks in your messages. You're essentially flagging specific chunks and saying, "Remember this." Anthropic caches up to 4 separate breakpoints per request, and the cache lives for 5 minutes, which resets every time that cache gets hit. So as long as your app is getting traffic, that cache stays warm and you keep saving money. Here's where it gets interesting for real production scenarios. Imagine you're building a legal document assistant. Your system prompt might be a few hundred tokens. But you're also injecting a terms of service agreement, a privacy policy, maybe a regulatory framework document that's easily 10, 20, 30,000 tokens of context that is identical across every single user query. Without caching, every question a user asks burns through all of that. With caching, you pay once to load it, and then every follow-up question in that session costs a fraction of what it did before. On a busy day with thousands of requests, that's not a small difference. That's the difference between a profitable product and one that's hemorrhaging money. The second feature that makes this genuinely powerful is how it interacts with long context windows. Claude supports up to 200,000 tokens in its context window. That's enormous. And it opens up a whole class of applications that weren't really viable before, things like codebase assistants that load your entire repository as context, customer support bots that have ingested hundreds of pages of product documentation, research tools that hold entire books in memory. The problem was always cost. Loading 100,000 tokens on every single request is brutal on your API bill. Caching makes these use cases economically sane. You load the big context once, cache it, and then run hundreds of user queries against it at a fraction of the original cost. Third, and this one surprises people, caching also makes your app faster. Not just cheaper. When Claude reads from cache, it skips the token processing step for that content. On large prompts, that shaves real latency off your response times. For a production app where users are waiting for a response, that's a meaningful improvement in perceived quality. Users don't know why it feels snappier. They just know it does. The fourth thing worth understanding is how to structure your prompts to maximize cache hits. This is where a lot of developers leave value on the table. The key principle is, static content first, dynamic content last. Your system instructions go at the top. Your injected documents go next. Your conversation history goes after that. And the user's current message goes at the very end. Cache breakpoints are evaluated from the top of the prompt down, so anything you want cached needs to come before the parts that change. If you put your user message at the top and your documentation at the bottom, caching won't help you at all. It's a simple structural rule: but it requires you to think deliberately about how you're assembling your prompts. Fifth, monitoring your cache hit rate. Claude's API returns usage metadata that tells you exactly how many tokens were read from cache versus processed fresh. If you're not logging this, you're flying blind. A healthy production app with prompt caching should see cache hit rates well above 50% on repeated query patterns. If you're seeing low hit rates, that's a signal that your static and dynamic content are getting mixed together, or your cache is expiring between requests because traffic is too sparse. So who should actually be doing this? If you're building any kind of AI-powered SaaS product where users interact with the same base context repeatedly, yes, this is for you. Customer support tools, documentation assistants, coding copilots, tutoring apps, legal or compliance tools, any application where the model needs to know a large body of information that doesn't change between queries. If you're a solo developer or startup trying to keep API costs low while you scale, prompt caching is one of the highest leverage optimizations available to you right now. It's not a micro-optimization. We're talking about cost reductions that can hit 60 to 80% on the right workloads. And if you're already at scale, if you're running tens of thousands of API calls a day and you haven't implemented this yet, you are actively leaving a significant amount of money on the table every single day. The one scenario where this matters less is if your prompts are almost entirely dynamic, like if every single call has completely different context with almost nothing shared. In that case, you won't get much out of caching. But that's a pretty narrow use case. Most real production apps have substantial static content that repeats across requests. Here's my honest take. Prompt caching is one of those rare API features that delivers on what it promises without a lot of asterisks. The implementation is genuinely straightforward. We're talking about adding a parameter to content blocks, not rebuilding your architecture. The savings are real and measurable from day one. And the latency improvement is a free bonus most people aren't even expecting. My only gripe is that the 5-minute cache window can be a little short for low-traffic apps or development environments where you're not making continuous requests. You might lose your cache between test runs and wonder why your costs aren't dropping. The fix is to structure your tests to hit the API in quick succession, or just know that in production with real user traffic, the cache stays warm. I'd rate this a strong 9 out of 10 for any team building production AI applications. It should be table stakes. If you're building on Claude's API and you're not using prompt caching, make it the next thing you add to your codebase. If you want to stay sharp on AI tools that actually matter for builders, not hype, not vaporware, just practical stuff you can use this week, subscribe and hit the bell. We drop new videos every week, and next week we're diving into how to build multi-agent systems with Claude without losing your mind or your money. See you there.